Okay, we are going to do homework 1, question number 1. So first question is determine whether the source given below has the potential to create a bias in a statistical study. So before we solve, before we choose the answer, I need to explain to you what is bias in statistics. Statistical bias is a term that used to describe population that don't provide accurate representation of the population. What population is? Population in statistics, we mean any subject of research. It can be, let's say, if I want to find out average age of population entire United States, then our population in this case is going to be all people in United States. If I want to research behavior of dolphins in the ocean, then it's going to be the dolphins population will be all dolphins in the ocean. Okay, so population, we use terminology of population, we use the subject matter we are interested. If I am interested in to study behavior of children, I'm going to take a group of children and study, and then whatever result I get, I'm going to apply to all children in general. Okay, that's what it is. And I can create a bias because I might have not all ages of children or only girls, only boys. That's with created bias. But when speaking population, we don't mean literally the population people. It can be population, we can consider birds, we can consider I don't know, all kinds of animals. We can consider people also. It's just subject matter. In statistics, we call population. So the bias in statistics is used to describe inaccurate representation of the population. Okay, or misrepresentation. For example, let's say in the room we have 20 people, they are girls and boys, and instead of asking, let's say, and boys and girls, not necessarily all 20 people, let's say several girls, several boys, that would be the right way to do, so to get the answer. But let's say I decided to ask girls if they like apples or peaches, and girls happen to like peaches. So this, let's say I questioned 3 girls. So result is going to be biased, correct? Because I didn't ask guys, and it just could be happened. These 3 girls out of 20, it happened to like peaches. So it can be intentional or unintentional bias created. Okay. So another example, there are several types of bias. I will go through every single one of them, but we are not in homework. We are going to use understand bias to figure out what is wrong if we have potential to create bias. Okay, bias also can occur when there is a tendency for the data to consistently overestimate or underestimate the true value that is being measured. It can be from that bias can be rise from all kinds of sources. So let's me bring example for different examples for different types of bias. Response bias. It arises when survey respondents provide inaccurate or misleading information due to factors such as social desirability, memory recall, or reluctance to disclose certain details. Okay? That's a response bias. Measurement bias occurred when the measurement instrument or technique systematically misrepresent or distort the true value that is being measured. What else? Next example, it can be statistical bias. No, hold on. Not statistical bias. Let's take next example, sampling bias. For example, let's say university researcher studies the students in his class and then draw a decision or make inference regarding entire human behavior. Obviously, here the university researcher is failing to account for the fact that students do not necessarily represent the general population. Well, students definitely represent important piece of population, but not entire general population. That's what we call, let's say, sampling bias. Another example of response bias is going to be when respondent to an environmental habit survey give answers that will make them look favorably rather than providing an honest answer, correct? Also, that can be non-response the bias. Let's say about 80% of registered voters refuse to participate in a political survey, causing the survey to not truly reflect voters' opinion, obviously. And there is also self-selection bias. So let's say a product designer solicits customers to test a new application interface, but only middle-income office workers volunteer to do that, meaning other types of people haven't been tested using the application interface. So that's a self-selection bias because we selected to represent it to middle class and rather than and middle and low and high class. And another example of measurement bias is when a sport medicine researcher forgot to calibrate the scale, so it consistently underestimates the weight of the study's participant by, let's say, 0.2 pounds. Okay, so that will be measurement bias. Another sampling bias when criminologist studies the causal factors of crime in one ethnic group in one neighborhood of a large city and generalizes the finding to entire population, not counting that entire population of the city is not the same ethnic group, right? And doesn't recognize different neighbors with different ethnic groups. And that would possibly give different result. And that's a sampling bias again. All right? So said that, we can start doing our homework and see where we go from here. Since there are several questions regarding potential to create bias, I will solve a couple and the rest I will let you finish it because usually in my math lab homeworks are changing, giving different cases, but with these problems by some reason they don't change. So problem stays the same, and at this point I don't want to solve it for you and you readily just place the answer. I'll just solve one or two and the rest, let's say 3-4 questions that following same type of question you will do yourself. All right, and one thing is you can take it unlimited until you get the right answer, and this way you will learn. All right, let's see what we have here. Finally, we got to solve our problem. The physicians' committees for responsible medicine tend to oppose the use of meat and dairy product in our life. And guess what? Organization has received hundreds of thousands of dollars in funding from the foundation to support animal protection. Now, you take a guess. Do we have here potential bias or not? I would say with a confidence, yes, we have a potential. They promote not to eat meat and dairy, and they receive money from animal protection support. Okay? So let's read what is going to be the case. It says A, there does not appear to be potential to create a bias. Since I decided for myself that there is a potential to create a bias, at this point I'm dropping all answers that says does not. And how many we have? A and C I'm dropping. So I have to choose because A and C says does not appear to be potential. And I'm not looking into these cases because I disagree with them, and I take it that there is potential to create a bias. And my answer is going to be either B or C. Let's read. There does appear to be a potential to create a bias, okay? There is an incentive to make the results statistically insignificant. I disagree with that because they do research, they want to know, do statistical study. So let's read the second one, the C. There does appear to be potential to create bias. There is an incentive to produce results that are in line with committee creed and that of its funder. Bingo! I believe this is going to be our answer. Let's check. There we go. Fantastic. So let me see if next question is going to be also bias in statistical study. I'll solve this one also in the following questions that will also look into statistical study of potential bias. I will leave it on you to solve. So let's see. Also, we need to look and source and decide if there is potential to create bias in a statistical study. So a data set includes brain volumes for 10 pairs of identical twins, monozygotic. So 10 pairs of identical twin. The brain volume is identical. The data were collected by researchers at Harvard University, Massachusetts General Hospital, Dartmouth College, and University of California at Davis. Okay, so right up front, I can mention that I don't see here potential to create a bias. Why? Because look at how many universities and hospitals they did the research. They couldn't, all these researchers, come to agreement that to represent same answer. If it would be one only, well, somewhat, I don't know, it could be a chance. But then we have Harvard University, we have Massachusetts General Hospital, Dartmouth College, and we have university. Four places it was researched, done the statistical study. At this point, in this case, I'm going to drop the answer that say does appear, which is going to be C and D. I'm dropping. I disagree with them. So I'm going to look for answer between A and B, right? Because I see that it's not potential, there is no potential to create a bias. So I will read both answers to find which one fit the best. Both of them can fit, both answers can fit, A and B, but one of them fit the best. So A, there does not appear to be a potential to create a bias. The organizations collecting the data are reputable. I would say this, yes, all these organizations, Harvard, Massachusetts, Dartmouth College, California, Davis, yes, But let's read just in case second answer also. There does not appear to be potential to create bias. Organization would not gain from putting spin to the data. No, doesn't. It sounds like baloney. So, okay, I am choosing this one. And the answer is final check. Nice work. So I did one example where there is potential bias, and another example when there is no potential bias based on my choice, my answer, which means you have to look into details and see what's the chance it can be bias. So what do we have here? Question number 3, let me read and I'll tell you I'm going to do it, or you are going to do it. Read the problem and find out. An article in I didn't see. Determine whether the given source has the potential to create bias. Okay, well then you can read it and do it. And the good thing it's multiple choice. You can try to think and understand what is going to be the answer in this case. So in this case, I'm moving to number 4. All right, several studies showed that after eating a very large meal, subjects had increased risk of heart attack. Oh, okay, so large meal increase heart attack. Which means don't go to restaurant, the plate is so big. The food is on the plate is so big. Actually, when speaking of it, I moved to United States from Europe. In Europe, if you don't know, when you go to the restaurant, on the big plate, there is a little bit food right in the center of the plate, a little bit. So when I moved from Europe to United States, and I went to the restaurant and I saw the load of the plate, I really was scared. I thought, what do they think about me? How can human eat this much? Well, guess what? After so many years, I went back to Europe when they served the meal in the restaurant. When I saw a tiny bit in the plate, I said, are you kidding me? Who can fill the stomach with this much food? So you get used to it. You get used to society and style of society. Okay, so let's read our problem. Several studies showed that after eating, and stop laughing. I know you are laughing there. So several studies showed that after eating a very large meal, subjects had increased risk of heart attack. A diet food manufacturer financed the research, identifying what is wrong. Okay, well, let's see. What is wrong with this statement? We need to understand. So I'm going to read all of them and then we figure it out what could be wrong. It's a diet food manufacturer financed. Okay. Since the research is composed of voluntarily responsible samples, there may be key data points missing. But we don't see it's a voluntarily response samples. We don't see that it was voluntarily, right? So it's a very tiny chance that could be the answer. Let's read next. It is not possible to take accurate measurement. Well, it's a chance. It's not possible to make because for some person it's a threat. Of some person is not threat because it depends on your body, your health situation. So you can't just like that measure and insist that eating large meal it's increasing a risk of heart attack. C, The data so far, A is possibility. So let's see the C. The data used in the studies is not reliable because it was not measured by the administrator. Now this one is completely baloney because I don't see any difference administrator or not administrator. And lastly, so I suspect last one is gonna be the proper answer. So let's see. It is questionable that the sponsor is a diet food manufacturer because the sponsor can be greatly affected by the conclusion. Bingo! So it is questionable that the sponsor is a diet food manufacturer because the sponsor can be greatly affected by the conclusion. So this is going to be my choice because we said diet food manufacturer financed it, right? So obviously it's going to be questionable. Okay, let's check. Good job. Moving to next one. Let me see what we have next there. So identify what is wrong. 12 nutritionists are each paid $100,000 to try new celebrity diet on 10 of their clients and then write a report summarizing the result. Okay. Based on the sample results, it is found that the diet is effective for 118 out of 120. Okay. So practically what we have, 12 nutritionists paid $100,000 to try this diet on 10 of their clients. Based on the sample result, it is found that diet is effective 10 of their clients. Okay, based on the result, they claim that the diet is effective for 118 out of 120. So let's read it. Answer A. The results have statistical significance but do not have practical significance. So first let's understand what is statistical versus practical significance. While statistical significance shows that an effect exists in a study, practical significance shows that effect is large enough to be meaningful in the real world. So statistical significance, that's a finding significance. That's a significance that they found as a result of research. And practical significance shows that effect is large enough, right? Its probability is high enough so to be meaningful to the real world. Okay? So let's see. What do we have here? Results have statistical significance but do not have practical significance. Well, we have 118 out of 120, right? So it's a large amount of people were affected, not effective, was effective for a large amount of people, 118 out of 120. Which means it's not the case, this one. Second answer, the sample of clients is self-selected. We don't see here how it is self-selected. Self-selected, it means it's just randomly selecting some people for the sampling, right? Let me figure out also what example that can be self-selecting. So let's say when volunteers for a study, researchers have to be very concerned about self-selection. The people that want to participate may be vastly different than the target population under study. So let's say people who are interested in one or another result, they volunteer to become part of that research, and this way it's gonna create bias. Okay, so people have a tendency to participate in the survey regarding issues they are against, and it will create opportunity to express a negative opinion on the issue that is upsetting or which they have a negative attitude about. Okay, so that is the case. So we don't see here self-selected, nothing point of self-selected clients, sample with self-selected clients. So moving to answer C. The nutritionists have a special interest to obtain results that are favorable to their bakers. I would say this is the answer. Of course, if the diet is effective, they will have more clients. Yes. And lastly, the sample of nutritionists is self-selected. We didn't see anything self-selection. Okay. Checking the answer. Well done. Moving to question number 6. Well, this is a math, more of the math purpose answer. In survey of 3,087 randomly selected US adults, 49% reported that they have at least one chronic health condition, such as diabetes or high blood pressure. Complete part A through D. Oh, okay. So part A, it's gonna be 40, if we have 49% of 3,087, what we are going to do? We take 0.49, right? 0.49, because we can't use in the format of percentage, so we convert to decimal notation, which is going to be 0.49. How I got 0.49? I take 49 divided by 100, because 100%, right? 0.49 times, I have 3087, and I'm getting 1,000, clicking 1,512. Okay. Okay, what is incorrect? Let me solve it again. To find, we need, no, adults. By 100 and, what is this? Let me do again, maybe sometimes my calculator is doing. So 3087 times 0.49. I didn't put decimal notation, okay. Dot 63. Yeah, I didn't read it. It says type an integer. Well, it says integer or decimal. It should take it. Blah, blah, blah. Well, it should take decimal, the integer. Now we take with decimal. Okay. So remember, guys, put decimal, it doesn't accept integer. Or if I would accept, I think I'm wondering if I would round up till 3, maybe. I didn't pay attention on decimal notation. Okay, so now let's read next question. Could the result from part A be the actual number of survey subjects who have at least one condition? I would say No, because in statistics there is always a high chance to be biased, or since they only tested 49%, 3,000 people they questioned, but our entire population is all people in United States. How many we have? 500,000, yeah, in population in United States. So that's entire population. So 3,000 people, even 3,087 under no circumstances can draw decision for 500,000. So at this point, for me, I'm going to drop answers with yes, A and C, and pick between B and D. So what is my B? No, the result from part A could not be actual numbers of survey because that the result is too high. That is also baloney. Result is too high. Yes, it's a high, but it's out of 3,087. It's not for entire population. Let's see what is the answer for D. No, the result from part A could not be actual number of survey subjects because a count of people must result in a whole number. Well, I would say most likely between A and B, at the B and D, I would say this one, because the true portion of it is when we are talking about adult, we don't talk about adults with decimal notation. We don't take 1,512 people and 3/4 of the person, right? So most likely it's gonna be D. Let's check, although no answer was smart, no choices were smart, but okay. And we have C, question C. So what's the actual number of survey subjects who have at least one chronic condition? So its action is going to be, with whatever number we got, 1,512.63, I'm going to round up. 1, 5, so it's going to be 1, 3, rounding up, because it's 63. Oh, but you never know, it might want to accept rounding, maybe it want to take 1512. Let's see. Yeah, it took the rounding, so you have to round it. Okay. So among those that surveyed, 1,527 were called by landline, and 1,560 were called by cell phone. What percentage of the survey subjects were called by landline? So what we gonna do here? So we are taking we are taking, since they are interested in landline, we are taking 1,527, and we are dividing by the total amount we had. How many surveyed? 3,087. And we are getting 49 point, how many decimals? 1 decimal. So if I round it, it's going to be 5. Okay, I got 49.46, so I'm rounding. Okay. What is wrong here? 49 point, they don't want me to round? Hold on. Put 4? What on the earth? Let me divide again. Maybe this is, so I used 2 attempts. If I one attempt also do wrong, then I have to start to do another case. So let me see. 1527, that's a landline, divided by We have 3087. 3087. Well, I got 49.5. Well, I'm going to open the answer. Let me see what it is. I'm curious. Didn't I put 49.5? I did put it. Well, at least you know what it is. Maybe that after 5 I put by mistake. But that's okay. You already know it's 49.5. We did it, right? So you take 1527. It's because it's a landline. It's asking for landline and dividing by amount sample size 3087. Okay, let's see what is in question number 7. Okay, looks like this is going to be the same question. I'm skipping so you can complete yourself. Moving to number 8. So let's see what we have. Research. Which question is that? 8. Research at the Sloan Kettering Cancer Research Center was once criticized for falsifying data. Among his data were figures obtaining from 5 groups of mice, with 25 individual mice in each group. These values were given for the percentage of successes in each group, 53, 58, 63, blah, 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 blah. What is wrong with those values? So to solve this problem, what we're gonna do, because we're gonna take these 25 individual mice, right? Mice in each group, and we need to convert into how much that means multiple it's gonna be, all these percentages. To find out, we are going to take 100% and divide by 25. Okay, so we take our 100%, and because we want to find out in the form of percentage, so we take 100% and divide by 25. 25 is a individual mice in each group. So in this each group, that gives you 53, 58. This is all for confusion. They threw more information than you need to. So 100 divided by 25, 100% divided by 25, it's going to be 4, which means all percentages of success should be multiple of 4. The given percentage cannot be correct, these percentages that are given. Okay. Well done. Moving to question number 9 to see what it is. Oh, here we are moving to qualitative and quantitative. Okay, let me make half of this assignment because there are 27 questions. So I'll record 8 questions in one video continuation with starting from question 9. Otherwise, if I record everything in one video, it will be difficult for you to find where question is where. You have to forward or rewind among 27 questions. And just so you know, it's I believe only this question is 27 question because a lot of definitions, a lot of understanding in statistics you have to know. All right? Okie dokie. Question number 9 will move to next question, next video.